In this video, we're going to talk about acid-base neutralization reactions. So neutralization reactions are when an acid is combined with a base and a neutral product is formed. Neutralization reactions are double replacement reactions, and acids react with stomach acid, HCl, and neutralize the acid to produce water, a neutral compound, and salt. Common bases used in neutralization reactions include ionic compounds containing hydroxide ions, ionic compounds containing hydrogen carbonate ions, and ionic compounds containing carbonate ions. So the reaction between acid and hydroxide ion containing ionic compounds produce water and another ionic compound. The hydroxide ion from the base combines with a proton from the acid to form water. And an equal number of moles of sodium hydroxide and HCl are combined. The result is a neutral solution. Sodium and chloride ions are unchanged during the reaction and remain in solution as spectator ions. The net reaction for these reactions are the hydroxide ion plus the hydrogen ion goes to neutral water. So practice. Answer the questions below about the neutralization reaction between aqueous hydrobromic acid and aqueous potassium hydroxide. So pause the video, and when you're ready, we'll come back and work on it together. Okay, so which solution is acidic? We have HBr, so hydrobromic acid, and potassium hydroxide. The acid is HBr, hydrobromic acid, and the ions dissolved in this acidic solution are the H plus ion and the Br minus ion. The basic solution is the one with the hydroxide ion, so KOH, and this goes to K plus OH minus. They are both strong acids and bases, and they completely dissociate. So write the complete balanced equation for this neutralization reaction. So neutralization reactions, we combine our acids and bases. So combine our acid and our base. They form water plus the salt of the cation of the base and the anion of the acid. So potassium bromide, KBr. We want to make sure it's balanced. We have one potassium and one bromide, two hydrogens and one oxygen, two hydrogens, one oxygen, we're good. The net reaction, we have to first write out our complete ionic and then determine our net ionic. So our complete ionic is we're going to write out our ions for each one. So H plus Br minus plus K plus OH minus goes to H2O. Remember, water is a liquid, and so we don't break up liquids in ionic equations. All the rest of these are aqueous. We can cancel out our bromine and our potassium, and our net ionic equation is H plus OH minus forms neutral water. And the spectator ions are potassium and bromine. Neutralization reactions with polyprotic acids. Polyprotic acids are acids with more than one acidic proton. So sulfuric acid has 2 acidic protons. Phosphoric acid has 3 acidic protons. Citric acid has 3 acidic protons as well. Remember, acidic protons are usually shown at the beginning of the molecular equation. All acidic protons can be donated in a neutralization reaction. And one hydroxide ion is needed to neutralize each acidic proton. Only one acidic proton can be donated at a time, and so there can be successive reactions, but all of them can be donated. So we can see here, we have a diprotic acid, so we have an acid with 2 hydrogens, so we need 2 hydroxide ions to neutralize it completely, and we'll end up with two waters. So we need two sodium hydroxides to neutralize the sulfuric acid. And the result is two waters. Spectator ions are combined in a ratio that forms a neutral salt for the ionic compound. So you need to also remember that SO4 is a 2- charge, sodium is a +1. So you need to make sure that you have this subscript 2 showing that you have two sodium ions to cancel out this -2 charge. So in summary, the reaction between an acid and a base to form a neutral product is known as a neutralization reaction. The reaction of an acid with a hydroxide ion containing base produces water and a dissolved salt. The net reaction is H plus OH minus goes to the neutral liquid water. The solution is neutral when an equal number of moles of hydroxide ions and protons are combined. A polyprotic acid is an acid with two or more acidic protons. In a neutralization reaction, a polyprotic acid donates all of its acidic protons to hydroxide ions to form water molecules and a salt.